All right, hello math fans. All right, so this is chapter, or the second part of this next chapter. All right, and what we're going to do is we're going to do adding and subtracting rational expressions. And today it's going to be like denominators. All right, so just real quickly, just to make sure we're understanding everything here, if I said 2/7 plus 3/7, okay, remember you're going to add the numerators, which is the same thing as saying the tops of the fractions, right? And the bottoms stay the same. So the denominator stay the same. Very important. So the answer to this one is going to be 5/7. Okay, and just think about it. You just be careful. I know sometimes it's tempting to add the top and bottom because we've done all this multiplying where you multiply the top together and the bottom together, but you don't do it at the top. And here's a good example of why it doesn't work. If I have 1/2 plus 1/2, if I would add the top and the bottom, I would get 2/4, right? And what does 2/4 equal? 1/2. Well, it's impossible. Come on, 1/2 plus 1/2 is not 1/2. 1/2 plus 1/2 is 2 halves, which is 1 whole. And that makes sense. A half plus a half is a whole. Okay, so keep that in mind. And again, for today, the only thing we're going to be doing is we're doing like denominators, so we just have to worry about adding the tops together. Okay, so let's do some stuff with variables. So 2x over 7 plus 3x over 7. It's very simple. It's 5x over 7. Now please, math fans, 2x plus 3x is not 5x squared. Remember when I taught it to you back in the day, if you have 2 x's and I give you 3 more x's, how many x's do you have? You have 5 x's. You have no x squares in your hand. You have just x's. So 2x plus 3x is 5x. All right? So same thing if I said, 5x squared minus 2x squared. If you have 5x squareds and I take away 2 of those x squareds, what do you got left? Well, you have 3 of the x squareds left. All right? Okay, so let's keep going here. If I have 5x over 3 plus x over 3, well, isn't that just 6x over 3? Because that's a 1 here. And then obviously try to simplify it. It's going to be a 2 and a 1, so it's just 2x. And always make sure, always reduce. Okay, here's the next one. 7x over 4 plus 3x over 4. That's 10x over 4. And again, you reduce, you get 5x over 2. Okay, let's put something in the bottom. 3 over 5x plus 7 over 5x. Well, that's just 10 over 5x. And then you reduce that. That's a 2 and a 1. So your answer is 2 over x. Okay, pretty mellow. Here's now, we're going to have something a little bit different on the bottom. X over x plus 2 plus 2 over x plus 2. Well, again, you add the tops together. You get x plus 2 on top, and on the bottom you have x plus 2. It's the same on the top and the bottom, so it's equal to 1. Okay, that's pretty mellow, because these both cancel, right? And when they cancel, don't say it goes to 0 either. That's really not good. Okay, the next one, 3x plus 2 over 2x plus 3 plus x plus 4 over 2x plus 3. Okay, you combine the tops together. 3x plus 1x is 4x. 2 plus 4 is 6 over 2x plus 3. Okay, your second to the last step, math fans, after you combine the tops together, you are going to factor. Okay, so you're going to factor. And you factor out a 2. And then you get 2x plus 3 on top. On the bottom you get 2x plus 3. Okay, I'm going to put that in parentheses just to kind of see that's all by itself. that crosses off, and I have 2 over 1, which is 2. Okay? So here's a rule so far we're going to have here. You never factor the top until the tops are combined. Okay? And you always factor the bottom if possible. All right. So let's start out with a nice little friendly problem here. X minus 2 over 3 plus 2x plus 8 over 3. And again, I know it's tempting to factor that 2x plus 8, but don't do it. It's after you combine everything. So x plus 2x is 3x. Negative 2 plus 8 is plus 6. Okay, now remember, now you're going to factor that, and you take a 3 out of there. And then the 3's cancel. So your answer is x plus 2. Okay, so far so good. Okay, a couple more examples. X plus 1 over x squared minus x minus 6 plus 1 over x squared minus x minus 6. So the thing I told you to do is I want you guys to factor the bottom. So we're going to do x plus 1 over, that factors to x minus 3, x plus 2, plus 1 over x minus 3, x plus 2. And then we combine the tops together. So that plus that is x plus 1 or x plus 2 over x minus 3, x plus 2. Okay, that cancels, and just because it goes away, you still have a 1 there. So that's your answer. 1 over x minus 3. Alright. Last example. 2x plus 9 over x squared plus 3x minus 10 plus x plus 6 over x squared plus 3x minus 10. Okay? Let's factor the bottom. That gives us x and plus 5 and minus 2. Okay, so 2x plus 9, x plus 6 over the same thing, x plus 5, x minus 2. Okay, combine the tops together. That gives us 3x plus 15 over x plus 5, x minus 2. GCF, man, always remember that. So it's 3 parentheses x plus 5 divided by x plus 5, x minus 2. So the x plus 5's cancel, and we get 3 over x minus 2. And that's your final answer. Okay? Anyway, those are all the examples for day 1. And again, these are unlike denominators, and the next lesson is going to be with, or these are with like denominators, and the next lessons are going to be with unlike denominators. All right, math fans, that's it. Have a good day. Goodbye.